Chapter 10 is about hypotheses tests regarding a parameter. This is the chapter that is what your project is over, so this will help you get some clarity on what you need to be doing for your project. First, we're going to do 10.1, the language of hypothesis testing. And so before we do that, we need to go over the learning objectives. So determine the null and alternative hypotheses, explain what a type 1 and a type 2 error is, and then state the conclusions of a hypothesis test. So first off, we need to talk about what a hypothesis is. So a hypothesis is a statement regarding a characteristic of one or more populations. And so in this chapter, we're actually going to only be looking at single populations and parameters. So a number that describes, remember, the population. And so a lot of the times, say in chapter 9, we were given a statistic and we were told to make an inference about the parameter. Now we're going to be already given a parameter and create a hypothesis test based on that. So we're going to be looking at claims regarding a characteristic of a single population, and we've got two different examples that we're going to look at. And in those two different examples, those are really the types of examples that we're going to be dealing with for the rest of this chapter, one being a proportion and one being an average or a mean. So I'll read the first one. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different. So the parameter here is 62% of American adults who regularly volunteer their time for charity work. And the test that we would be conducting is that this researcher believes the percentage is different. And we'll get into this a little bit more, but these are just straightforward examples. The second one says, a fabric softener company claims that a certain size bottle will last for 40 loads of laundry on average. So that 40 loads of laundry on average is your parameter, and it's a mean. And then a consumer believes that this estimate is too high. So that's really what hypothesis testing is in a nutshell. It's we'll be given a parameter. Say, let's use this second example. So I go to the store and I get this bottle that it's talking about, right? And it tells me that I'm going to get 40 loads of laundry. And I start doing loads of laundry and I'm talking to myself and I'm like, I think I only got, say, 30 loads of laundry this time, or I only got 35 loads of laundry. So there's no way that this 40 is actually correct. And so that would me saying, I think that this estimate is too high. I don't think I'm going to get 40 loads of laundry out of this. And so hypothesis test is basically you questioning the parameter. So we're given something and we're going to question it. I think it's too high. I think it's too low. Or I think it's different. If a population data are available, there's no need for inferential statistics. So the stuff that we did in Chapter 9, we inferenced. Say we found a statistic and we created a confidence interval based on that statistic because we said we think the population's somewhere between here and here. But in Chapter 10, we're going to be given the population, and if we're given the population, we don't need to find statistics because the whole point of statistics is to figure out what the population is. So if we find and we have the population, then we're good. We don't have to need inferential statistics. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding the characteristics of one or more populations. Again, we're just going to be doing one in this course or in this chapter. But we will be testing statements. We will be saying, I don't know if that's true. I think it's less than, more than, not equal to, whatever it may be, and we'll look at what that's going to look like in a little bit. So general steps in hypothesis testing is make a statement regarding the nature of the population, collect evidence to test the statement, and then analyze the data to assess the plausibility of the statement. And so this is really what your project is over, to be completely honest, in a nutshell. But for a lot of examples in class, you're not going to be asked to collect all this data and analyze it. You'll just be asked to analyze for the most part. So you're going to have two types of hypotheses, a null and an alternative hypotheses. The null is denoted H sub O. It's not supposed to look like that. It actually looks like this, and it's a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference, and is assumed true until we prove that it's not true. So it's kind of like the court system. We assume they are innocent until proven guilty. The null is assumed true until proven untrue, until we find evidence that it's not. And then we've got something called the alternative hypotheses, which looks like H sub 1 or H sub A. I always use H sub A. It looks like ha, because it just reminds me that the A stands for alternative, and it's a statement that we're trying to find evidence to support. These are basically all the different situations that will happen in this chapter. I'm going to change all these really quick. H sub O, H sub A, H sub O, H sub A. For some reason, the formatting is always weird on subscripts. But there are three ways that we're going to set up the null and alternative. Do notice that the null is always equal to. So it's always going to be our parameters equal to some value. And then our alternative is the one that we're saying, I don't think it's actually equal to 40 loads of laundry. Or I do think it's less than 40 loads of laundry. Or I think it's more than 40 loads of laundry. So it's always going to be our parameter, and it says parameter because it can be a mean or proportion, and then equals whatever value. So maybe that one example, we could say mu is equal to 40 because it was equal to 40 loads of laundry. And then maybe I think that it's actually not equal to 40 loads of laundry. So that's the thing I'm going to test. But that's just an example of what it could look like. So, just to reiterate kind of what a hypothesis testing is overall, or that we've learned so far, is the null hypothesis is a statement of status quo or no difference, and it always contains a statement of equality, so it's always equal to. The null hypothesis is assumed to be true until we have evidence to say it's not. Innocent until proven guilty, basically. We seek the evidence that supports the statement in the alternative hypothesis. So we are trying to prove that the alternative hypothesis is true. Okay. When we are testing hypotheses, one of the first steps is actually forming the hypotheses. And so in order to form a hypothesis, we need to determine the null and alternative. We need to figure out if it is a mean or proportion. We need to figure out if it's two-tailed, left-tailed, or right-tailed. Two-tailed would give us the inequality not equal to. Left-tailed would give us less than, and right-tailed would give us greater than. So I would definitely write that down somewhere. But I'm going to go ahead and move on with the examples. So in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes this percentage is different today. So 62% is the number we're looking at, and we believe that it's different. So there's words that you need to look for that will tell you what kind of tail it is. So different is what we believe, what we're trying to prove. So you're always going to have a null and an alternative. Then you're going to have what the parameter is. So 62% is a proportion. So it's going to be P. And the null, the first one, H sub O, is always equal to whatever. In this case, our 62%. The alternative, we're not going to change the 62%. The 62% is going to stay. The only thing that changes is the inequality sign. So we believe it's different. So what does that mean? Less than, more than? It's very vague. And because it's so vague, it's going to be a not equal to. Different could be less than or greater than, right? It's again, very vague. So that is our hypothesis test. So it's always your hypothesis, your parameter, and then your number. So I'm going to erase that and we're going to keep going. So the second one, B, according to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since that time. So, again, I'm always going to set up my null and alternative. And I need to figure out what the parameter is. It's talking about mean. It uses the word mean. And it will use the word mean or average if it's talking about a mean. And then the number that I care about is that 3.25. So the null is always equal to the number it gives us. We still write that 3.25 for the alternative, but what we're trying to figure out for the alternative is the inequality sign. And the word increased was used, which makes us think that we believe that the average is actually bigger than 3.25, or it's increased. So we believe the mean is actually greater than 3.25. So this is a right-tailed test. And that is how we do B. C says a software company claims that a certain size bottle will last for 40 loads of laundry on average. That means mean. A consumer believes this estimate is too high. So if we think it's too high, that actually means that I don't think I'm getting 40 loads of laundry out of this. I think it's less than 40 loads of laundry. So again, I'm going to do my null alternative. It said on average, so it's a mean. The first one's always equal to whatever number, in this case 40. And the second one, we're still going to use 40, but we're going to use the inequality that they are suggesting. So we think that it's too high. We think it's actually less than 40 loads. So that's going to be a less than sign. We believe it is less than 40, and that is our setup for C. D says in 2012, 15.9% of all U.S. families had incomes below the poverty level as reported by the U.S. Census Bureau. A local politician believes that the percentage of all families with income in Midland with incomes below the poverty level is less than that of the nation. So this one's tricky. We're trying to take a statistic from the so our population is 15% of all U.S. families. And our local politician, is trying to say specifically in Midland. So this one we can't do because it's trying to take a parameter about the country as a whole and do it specifically for Midland. If this sets 15.9% of all Midland families had income, then we could try to question about Midland. But you can't question it if originally the parameter didn't say specifically Midland families. If a local politician believed that the percent of all families in the U.S. with incomes below the poverty level is less than, then we could do a hypothesis test. But this is a little messed up because it's kind of going into waters that you can't go, basically. So this one we can't do. If it was reworded, we'd be able to do it. If it was talking about U.S. families, but we can't talk about Midland specifically if it originally didn't talk about Midland specifically. There are errors that occur when statisticians conduct hypothesis testing. So any decision that we could make could be incorrect. There are two types of errors when you do hypothesis testing: a type 1 and a type 2 error. A type 1 error is rejecting the null when it's in fact true. That would be like sending someone to jail when they're actually innocent, right? That's an error on the court system. And then a type 2 error is not rejecting the null when it is in fact false. So that would be like not sending someone to jail when they are guilty. Here is a table that will help, but let me draw the little bars to help you see what it looks like. There we go. Okay. So in reality, the null is true. So if the null is true, so here I am. If the null is true, the correct decision is not to reject, because that's saying we couldn't find evidence, so we do not reject. That's the correct way about going. Or if the null is false, we say that we reject, or we say it's guilty. If it's false, we reject. That's the right outcome. If we do the opposite, then that's where the errors occur. So if we say it's false, but we do not reject, so guilty, but we don't send to jail, that's a type 2 error. Or if we say it's true, but we reject, so innocent but send to jail, that's a type 1 error. I know this may seem really confusing right now, but we will be okay, I promise. Okay, for each of the following claims, explain what it would mean to make a type 1 error. What would it make to make a type 2 error? So for A, 62% of adults regularly volunteered their time for charity work. A researcher believes this percentage is true. So for A, I'm going to do this down here. I'm going to state my null and alternative again. We've already done this one, but we already created the test, I would say. We believe it was different, so not equal to 62%. So for a type 1 error, I'm just going to call it T1. That would be us saying that it's not 62%. So that's saying we found evidence that 62% of American adults do not volunteer their time, but really they do. We incorrectly read the data or whatever it would be. So that's why it's an error. So we said 62%. Actually, I'm going to say it's not 62%, but really it is. So that's the error, because we're basically lying on accident because it's an error on our part. A type 2% is we say, yeah, the 62% is correct. Say it is 62%. But really it's not. Really it is different. Sorry. Running out of room. The same could be said for B. According to a study published in March 2006, the mean length of a phone call was 3.25 minutes. A researcher believes the length of the time has increased. So maybe we say, no, it's not 3.2 minutes. It has increased, but really it hasn't increased. It was 3.2 minutes. That would be a type 1 error for this example. And then a type 2 error is it really is 3.25 minutes, but we say it has increased. So that would be an error on our part because we're providing false information basically. Alpha represents the probability of a type 1 error, and B represents the notation for a type 2 error, beta. I would say we don't really see this very often, but we do just need to kind of go over it so you know that it exists. But again, we don't really hype on that too much in this class. We deal with more of the calculations behind hypothesis testing, but if you do see any of this in your homework, that's where it came from. So the probability of making a type 1 error is alpha, and it is chosen by the researcher before the sample data is collected. The level of significance, or alpha, is the probability of making a type 1 error again. So level of significance, we are going to see that again. That is something that we're going to talk about a little bit more in 10.2. So just be careful. We never say that we accept the null hypothesis because without having access to the entire population, we don't know the exact value of the parameter stated in the null. Rather, we just say we do not reject. This is just like saying we don't say someone's innocent, but we do say they're not guilty. So instead of saying we accept, we just say we reject or we do not reject. And that's the vocabulary that we'll be using in 10.2. Okay, lastly, we've basically in this section, we've talked about how we're going to start hypothesis testing with the null and alternative, how we set up. And now we're going to talk about the conclusion. And then everything in between those two is in 10.2, basically, all the steps from where we start and where we conclude. But according to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. Suppose the sample evidence indicates that the null hypothesis should be rejected. State the wording of the conclusion. So if we were going to state the wording of this conclusion, all we would say is we reject because it told us. And how we know if we reject, that's what we're going to learn about in 10.2. But let's just say it tells us that we're going to reject. So we say we reject the null, which was mu was equal to 3.25 minutes. And that is how you would reject. If we say in B, it says, suppose the sample evidence indicates that the null hypothesis should not be rejected. So again, remember we don't say accept, like we don't say innocent, we just say not guilty. Or in this case, if it should not be rejected, we say fail to reject the null, which is that the mu is equal to 3.25. And that is how we conclude what we'll be doing in 10.2.